Hello students, now let us see another very important theorem, angle bisector theorem. I'm sure you would have studied the first theorem, basic proportionality theorem. Okay, that's one of the very important one. And this is the second very important theorem, angle bisector theorem, ABT. Angle bisector, bisector means you divide into two equal parts, right? Angle bisector means the angle you divide into two. Suppose angle A is 60 degree, through 30 you draw a line. So that line we call it as angle bisector. Okay, I'll explain to you what is angle bisector theorem. Then we'll see the statement. So since there is a name, so you have to learn the statement because question can be asked as state and prove angle bisector theorem as a 5-mark question. You write the statement as it is given in the textbook. Okay, and as a 2-mark question they can ask state angle bisector theorem. So it's a very important one. So please listen here. What is angle bisector theorem says? See, a triangle is given. ABC is a triangle. You take one angle, any one angle you take. For example, I'm taking this angle. This angle A, I'm bisecting. That is through this A, through this, suppose the angle A is 60 degree. Through 30 degree, you draw a line. It need not meet at the midpoint. Okay, suppose this is E. So A is the angle bisector. That means the two angles are what? Equal. What can you say here? AB by AC is equal to BE by EC. Okay, suppose if I take this as D. AD is the angle bisector. Then you can say AB by AC is equal to BD by DC. Okay, so AB by AC is equal to BD by DC. So to prove this one, so we need AA similarity. How can you prove two triangles are similar? One method is AA similarity. Two corresponding angles are equal, then you say the triangles are what? Similar. Then another important thing you need in a triangle, suppose two sides are equal. If two sides are equal, then you know that two angles also equal, right? So with this ideas, you can do this very easily. Now let us see the statement. The internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the corresponding sides containing the angle. So this is the angle. The sides containing the angle means this AB and the AC. Okay, so here the third side internally divides. So BD by DC is equal to AB by AC. Okay, now let us see how to prove this. See, this is the diagram. So what we do here, this AD is the bisector, right? AD is the bisector. Through C, you draw a line parallel to AB. So that is one construction. Through C, you draw a line parallel to AB, which meets this AD produced. What is AD? AD is the angle bisector. So this angle you divide into two, right? So both angles are equal. If this angle is 1, this angle is also 1. So this AD, you extend it, and that AD produced and CE meet at a point what? E. Now listen carefully. So what is given here? Triangle ABC. In triangle ABC, AD is the internal bisector. See, now the triangle is like this. Triangle is like this. I am taking A as this point, ABC. So please listen here. AD is the bisector. AD is the angle bisector. AD is the angle bisector. Then what can you say here? AB by AC is equal to BD by DC. AB by AC. So to prove AB by AC is equal to BD by DC. Okay, please look into the construction again. So what we are doing here, through C, you draw a line. Look at this rough diagram. Through C, you draw a line parallel to what? AB. AB and this line are what? Parallel. And you extend this AD. AD you have to extend. Now that meet at a point what? E, you are getting this diagram. Okay. Now listen here, for the proof, you take these two triangles. Can you prove these two triangles are similar? Very easily can prove. Because these two lines are what? Parallel. So this is a transversal. So this angle and this angle are equal, alternate angles. So if I take this as 2, this is also what? 2. Then these two angles, then even these two also you can say, this angle and this angle alternate angles. I have taken this as 1, so this also must be what? 1. And moreover, these two angles are equal, vertically opposite angles. Even two angles enough, you can say by AA similarity. But you know, if two angles equal, definitely the third angle also equal because of angle sum property. When you add all the three angles, you will get what? 180 degree, right? So by AA similarity, the two triangles are similar. Then you can say, please listen here. And one more thing you can say, this is angle 1, this is angle 1. The two angles are equal. So you consider this triangle ACE. Look at that triangle alone. ACE. We are proving these two angles are equal. Once you prove that two angles are equal, the two sides also equal, right? That also we are going to use here. Okay. Construction, draw a line through C parallel to AB, extend AD to meet the line through C at what? E. Now listen the proof. First we prove that two triangles are similar. We consider the triangle, okay? Consider triangle ABD and triangle ECD. See, ABD and ECD, the two triangles we take. So you can say here angle 2, that alternate angles are equal, right? So this 2, that is ABD, angle ABD equal to angle ECD, angle ECD. Okay, both I am taking it as what? Angle 2. What's the reason? Alternate angles. Okay, now another two angles. This 1 and 1 we mark, right? So angle CED, angle CED is equal to, that is from the second one it is CED, from the first one, which angles? CED, this angle and this angle. So what's the name of that? BAD. BAD is equal to CED. BAD. Angle BAD is equal to angle CED, and both angles are what? 1. The reason is same thing, alternate angles. And one more, the angle 3 equal, vertically opposite angles, right? So CDE, angle CDE is equal to angle BDA. Angle BDA. So both angle you take it as 3 vertically opposite angles. Alternate angles are equal, vertically opposite angles are equal, right? So by AA similarity, or all the 3 A's you write, 3A, so AAA similarity. You can say triangle ABD is similar to triangle ECD. So you know the corresponding sides are proportional. What you need we take, okay? For the small triangle, so these are the two triangles, okay? Which two triangles? This triangle and this triangle. We prove they are what? Similar. So you can say the corresponding sides are proportional, right? So if I take AB, here you take CE. AB by CE. AB by CE equal to, so if I take BD, here the corresponding side is what? CD. BD by CD. BD by CD. Now listen, to prove BD by CD, yes, here also BD by CD or DC both same only. Here numerator is AB, here also you got numerator AB, but the problem is here CE, what we have to prove? AC. CE and AC. CE and AC, are they same? Yes, they are same only. Here I said no, when the two angles are equal, the two sides also equal. Here the two angles are equal, right? This is angle 1, this also angle 1. So you have to say the reason. But CAE, angle CAE is equal to angle CAE is equal to angle AEC. AEC. So the two angles are equal, so you can say the two sides also equal. So CE is same as AC. CE equal to AC. These two sides are equal. CE. That value you substitute in the first equation. So numerator no change, AB. Riser also no change, BD by CD. But only the CE can be replaced by what? AC. So hence proved. Very simple proof only, but try to understand first. Okay, we prove that two triangles are similar, right? AA similarity we are using. Then two angles are equal means the corresponding two sides also equal. Okay, don't try to mug up. Write and see 2-3 times. You can make it very easy. Okay, hope you understood this one.